And in this chapter, we will talk about the third kind of the motion of an particle. So far, we talk about the translational motion. Okay. The translational motion. Okay. The translation motion is a motion that we have the net displacement of the object. Okay. For example, if you have an object like this and you move along this path to the new position, you can see that you have the net displacement vector like this. So we call this kind of motion the translational motion. The second kind of motion is the rotation. Okay, this is the rotation. The rotation is the motion of the object around a fixed point. For example, an object moves in a circular path around fixed point, which is the center of the circle. You can see that in this kind of motion, you don't have the net, or on average, you don't have the net displacement, because the particle will move back to the original or to the initial position in each period. Okay, so on average, the particle go nowhere. It moves around the center. So we say that the rotation, in the rotational motion, there is no net displacement. Okay. And the third one that we will talk in this chapter is the vibration. The third kind is the vibration or oscillation. Okay, we use the name oscillation. Okay, the oscillation is similar to rotation, and we will show you that there is a close connection or the close relation between the rotation and oscillation. For the oscillation, the particle moves back and forth we may define a point x that we will define it in more detail later, and we may call it this x is 0 here. So the object moves back and forth between x equal to 0, so it may go to the x equal to the minus a to the x go to the plus a. The point x0, we may call it the equilibrium point, equilibrium point or the relaxation point. Okay, it's equilibrium point or relaxation point. Again, in oscillation, the particle have no net displacement. You can see that it will go back and forth, and will move back to the original point in each period. So we don't have the net displacement for this kind of motion. And you will see that, as I told you, that it is a very close relation between the rotation and oscillation. Okay. So in this chapter, we will talk about the third kind of motion, the oscillation, the oscillatory motion. We will start by define, not define. Start by consider the simplest system that have the oscillatory motion, that is, it is the system of an object attached to a spring. And then we will talk about the mathematics of this system, the analysis model, which the result is the so-called simple harmonic motion, which is very important. We can use the idea of the simple harmonic motion to describe many things. Not only the particle attached to a spring. We can use it to explain the vibration in the molecular level, to the vibration of the, even for the building, many things. We can use the simple harmonic motion. Okay, so we will talk about it in detail later. And then we will look at the energy consideration, the energy of the simple harmonic oscillator. And now, this is what I told you. This is a close relation between the simple harmonic motion and the uniform circular motion. And in this section, we will discuss on this relation in detail. And as I told you, the simple harmonic motion can be used not only for the system or for the object attached to the spring. We can use it to describe much more things. One thing is that we can use the idea of simple harmonic motion to describe the pendulum. Okay. For some condition, the pendulum, the motion of the pendulum is or has the form of the simple harmonic motion. Anyway, the simple harmonic motion is quite an ideal system. In a real system, you don't have only the force from the spring, but you have, for example, the drag force from the air, the frictional force. Many forces are involved with the motion. So, to make it a little bit more realistic, we will introduce the damp force into the system, and it results in the damp oscillation. We can also force the oscillation. It means that we force an object to move in the pattern that we want, and if the pattern is a kind of oscillation, we will call it the force oscillation. Okay, so the last two section is the more realistic motion of the system, or the more realistic condition for the system. Okay.